In this question, it is given that the number of elements in the set this and satisfying this inequality is dash. First of all, you must be knowing that mod of z minus z0 less than r represent the set of all the complex numbers which are at a distance of less than r from the fixed point z0, that is all the points lying inside the circle with center z0 and radius r. All these points lying inside will satisfy this inequality. That is, in other words, the meaning of the question is you have to find all possible integral value of a and b, that is all possible values of z which satisfy this inequation. The meaning of the question is this inequality implies that 1 is less than mod of z minus 3 minus 2i less than 4. That is, we have to find the number of integral points which lie in this circle with center 3 2 and radius 4 and lie outside a circle with center 3 2 and radius 1. That is, you have to find the number of integral points lying in this portion. But we know that when we subtract 3 or 2 from some integer, after subtraction also it will still remain an integer. And using that distance formula, I can easily say that this equation represents set of all those points which lie between two circles, both having center 3 minus 2, one having radius 4, other having radius 1. Radius of this circle is 1, radius of this circle is 4. That is, in other words, this equation represents all these points. But we have to find only the integral points lying in this region, because a and b are given to us as integers. To make the question simple, I shift the origin 0 0 to the point 3 minus 2. By shifting of axis, number of integral points will not change. If this is some integral point, after shifting of origin from here to here, the coordinates of this will change, but still it will remain an integral point. And by shifting of axis, my calculation will become smaller. Hence, we now conclude that we have to find the number of integral points lying in this portion. This point is 1 and this point is 4. Obviously, to find the number of integral points in this portion, I will just find the number of integral points in this region and multiply it by 4, because number of integral points in this region, this region, this region and this region will be equal. But note that in this region, if I include the points of this, then I will have to exclude the points of this, because otherwise this will be counted in this also and this also. Therefore, I just find the number of integral points in this region, excluding the points on this but including the points on this, and then I will multiply it by 4. Clearly this is 2, 3 and 4, but because equality is absent at both the places, hence 1 and 4 will be rejected. One integral point of this region is 20 and 30. After this and this, more integral points will be, from here I can say 1 1. 1 1 is also an integral point in this region. Next integral point is 2 1, and next is 3 1. I can surely say that 3 1 will also lie in this circle because distance of 3 1 from origin is less than 4. 4 is here. And one more thing you should take care of it is, if I draw a line making an angle of 45 degree with x-axis, 1 1 will lie on that line. I will just find the number of integral points in this portion. Number of integral points in this portion and in this portion will also be same, because if it is 2 1, the image of this will be 1 2. If 2 1 lies inside the circle, then 1 2 will also lie inside the circle. Therefore, I just find the number of integral points in this portion, that is the number of points which have x coordinate bigger than y coordinate, and for x coordinate equal to y coordinate, those points will lie on this line. Hence, so far we have got this point, this point, this point, this point and this point. Next will be 2 2. I will not count 1 2 because 1 2 comes in this portion. I am going to find the points in this portion. Note that I will count these points only once. Let us see whether 3 2 comes in this portion or goes outside. It is 3 1, 3 2 will be somewhere upper. Distance of 3 2 from origin will be 9 plus 4, that is less than 4. Hence 3 2 will also lie in this portion. This will be 3 3 will be coming on this line, and 3 3 will be outside also. Therefore, so far we have counted number of integral points as this, 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 this and this. That is 5 integral points. Note that these 2 points are lying on this line. If 5 integral points are here, obviously if these 3 points are in this position, their mirror image 1 2, 1 3 and 2 3. These 3 will lie in this position, that is 3 plus 3, 6 and 2 points here, 8 and 2 points here, 10. Hence we have found that in this portion number of integral points excluding the points on this is 10, and because of symmetry I can say total number of integral points will become 40.